Hi, we are Team VA3200 and we worked and collaborated with VantEdge Labs, founded by Pritish and Brian, both PhD students in computer science with expertise in cloud infrastructure and distributed systems. Their platform helps organizations deploy, scale, and manage AI applications in the cloud without requiring extensive expertise. AI workloads have unique resource requirements and performance characteristics, and organizations today may not have all the resources or knowledge on how to deploy and manage these AI applications. They may lack visibility into application health and performance, struggle to monitor resource utilization effectively, and find it difficult to manage complex cloud resources. This problem impacts multiple types of stakeholders who want to deploy and monitor their AI applications, such as DevOps teams who don't know proper infrastructure maintenance, data scientists that may face challenges when deploying models to production, and business stakeholders that lack clear visibility into costs and performance metrics. Without proper monitoring, organizations can't optimize their AI deployments effectively, which is the specific problem our team tackled. Our solution is a comprehensive, real-time analytics dashboard integrated with the VantEdge Labs platform. It provides monitoring of container health and resource utilization, tracks application performance metrics, visualizes cloud costs, and offers customizable alert configurations to meet specific monitoring needs of the user. Now that you understand the context and purpose of our project, let's see the dashboard in action. In the following demonstration, we will show you how users interact with the dashboard to monitor their AI applications and receive alerts about critical events.
This is the homepage of our VantEdge dashboard platform. A first-time user will need to sign up to unlock all the functions provided by the VantEdge dashboard system. Upon providing a valid email address, password, and a matching VantEdge access code, users can successfully sign up. Having logged into the VantEdge dashboard system, users will also need to require to log in to the embedded Grafana server account through this pop-up Nginx proxy user interface. User can make it by providing the same username and password as their VantEdge account. Since this second layer security feature is optional, it has not been included into the deployed version. And also access to the Matrix Handbook tutorial, which provides a full and clear explanation for all of the metrics showing on their dashboards. It benefits users by developing their skills and knowledge into understanding their dashboards. By clicking on Logout, users will leave the VantEdge system entirely. However, all of their operations on dashboards and alerts selections have been saved and will be retrieved automatically when users log into the system next time.
On the main page, users will see their unified dashboard, which displays an overview of various metrics, all sorted by the type of metric, and this makes it easy for teams to see their application health, their spending, and much more all in one place. Users will have their applications run by VantEdge, and VantEdge will run their applications in the cloud. To track the incurred costs, users can look at the cloud cost section here. Here they can track the cost of each individual instance running for their application. If one instance is consuming more resources than expected, it's easy to spot and they can take action to optimize costs. Here, there's a graph for total usage cost over time. User can also hover on parts of the graph to get more details about the exact cost and the time. They can also see their EC2 network data transfer cost breakdown, which shows how much data is being transferred between their EC2 and external resources and how much they're spending on this. So now let's say that the user is a backend developer for the application. They need to understand what's happening in their applications without having to sift through raw logs, and they want to spot problems fast. In this section, users can see application log metrics. They can see the overall error count per minute, and they can also see the HTTP status code trends over time. For example, if they see an increase in 500 errors, this could indicate server-side issues, and users can see this immediately and look into which services are failing and why. They can also filter the time to get a more granular view of their data.
I will go through the second part of the dashboard. First, we are tracking application level latency, including P95 and P99 latency over time, which help users to detect performance degradation before they impact the majority of users. And then we look at container CPU usage and memory usage over time. This shows us how much computing power and memory each container consumes. Consistent high usage can be a sign that users need to scale or optimize the service. Next, we have CPU usage efficiency. This is a measure of how efficiently the user uses CPU, and also network power. That's a measure of container network performance. We also monitor container disk usage and network performance, including received bytes, transmitted bytes, network errors, and drop packets. This is crucial for detecting I/O bottleneck, broken connections, or traffic spikes that may affect service quality. Since we run multiple services on a single VM, we also track host-level metrics. This includes host CPU, host memory, and also network, as well as disk usage. This gives us a broader view. If multiple containers are underperforming, but the host CPU is okay, then it might be due to resource contention. Conversely, if a container is struggling while the host is fine, the issue is likely service specific. The full stack view, from application down to container and host, lets us to correlate symptoms to causes quickly, so that user can troubleshoot faster, improve resource efficiency, and ensure the reliability and stability across the service.
While the dashboard itself provides us with a great amount of data about all metrics that are measured, sometimes we want to know if something goes wrong while we are not looking at the dashboard. To this end, alert notifications have been implemented. Whenever specific metrics behave in relevant ways, an alert can be triggered and a notification can be sent to the user email that we logged in with. We can click on the Alerts tab to get a list of default alerts that have been constructed, and we are given the ability to select which of these we wish to receive a notification for. For example, the low throughput alert is triggered whenever the requests per second go down and stay down for at least 10 minutes. Let's say the user is a developer and they expect their application to be used with a relative frequency. If this alert is triggered, it might indicate that something's wrong and they need to know about it. So they select it and click on Save Changes. The application will continue to run normally and the dashboard will continue monitoring it. But after an arbitrary amount of time, if the alert gets triggered, the user will receive an email like this. And at any time of day, if they receive an alert email, they can immediately know what's going on and be able to correct things right away. This now concludes our demo. On behalf of the team, thank you for your time.